Alrighty, welcome back in chemistry video 2.6. Here we're looking at representing data, more importantly, how to graphically represent data to reveal patterns in data. Make sure you turn off your phones, social media should go away, no distractions, pause, rewind as needed, and take some notes in the margins, and ask those questions in class should you need to. Here we go. So, graphs. Graphs are basically just visual representations of data. When you graph things out, you start to see some kind of patterns. That's why we do it. There's three major types: circle, bar, and line. It turns out the line graph is probably one of the more commonly used ones in chemistry. When you go to graph something, on the x-axis we plot the independent variable. And if you remember from earlier, the independent variable is the one that we manipulate and change. On the y-axis, we plot the dependent variable. So we change this one, and then we measure how the dependent variable changes according to that, because it depends on this one, and then we can plot that out. So here we have Fred. Fred is measuring the volume of 4 different aluminum objects with assigned masses. So these have been assigned, so that's going to be our independent variable. And then we're going to measure the volumes. As you can see, as the masses get bigger, the volumes get bigger as well. So the volume does depend upon how much mass you have present. So when we go to graph, a couple things you want to do. Make sure you put a title on your graph here. So I guess this title here would be mass and volume relationship. So always put a title on your graph so we know what it's about. And then, like I said, we are going to manipulate the mass here, and there they are. So that's going to go on the x-axis. And when you go to put stuff on here, you want to really make the most uses as you can. You may want to have a little bit left over for a thing called extrapolating we'll look at later. So let's see here. We go from 10 to 50. And we technically start right here, and it goes 1 tick mark, 2, 3, 4, 5, 6, 7, 8. So you have 8 here. So it kind of makes sense to go by tens, because you'd have a little bit left over. So we would go 0, 10, 20, 30, 40, 50, 60, 70, and you guessed it, 80. And let's also label that axis as well. So this is going to be the mass on the x-axis, and the masses are in grams. Next, we're going to do volume, and it goes from 3 up to 18.5. So I'll just kind of round to maybe 20-ish. So let's count and see what we have on the axis here. We go 1, 2, 3, 4, 5, 6, 7, 7 here. So if we go by 5s, that should work out pretty good. We use most of the space here, so it's going to go 0, 5, 10, 15, 20, 25, 30, 35. And going by that increments there, it's pretty good. We're going to get to about here on the graph, and we can maybe stretch out maybe a little more, maybe go by 4s. But the idea is use most of your graphing space, maybe have a little bit left over so you can pull out farther should you need to. So let's graph our data now. Oh, don't forget your axis here. So this is going to be volume. And our volume is in cm cubed. Okay, so now let's graph it out. So at 10, we have 3.7. So at 10, we have about 3.7, so we would make a mark right there. At 20, we have about 7.45, so approximately right here. Ooh, come on. There we go. At 35, so about here, we have 12.5, so right about there. And at 50, we have 18.5. So 50, 18.5 would be about up there. So that's our plotted points there. So you can see here, mass and volume vary directly. If one thing goes up, so does the other thing, and vice versa. If one thing goes down, so does the other variable. Inversely would be one goes up, the other goes down. And then with this data here, basically, it kind of looks very nice and linear, like so. You can see the graph goes like that. Okay, so this is plotting data. Make sure you put a title on there. Make sure you label your x and y axes, and also kind of scale it appropriately so you use most of your graph and allows for the extension of lines should you need to with your data. When we look at graphs, we have a thing called interpolating. Interpolating is when you read values on a graph between. The prefix inter means between. So if you read between data points, you're interpolating data. So completely random, different example here. It says, what would the temperature be after heating for 45 minutes? Well, if we go 45 minutes into this particular thing here, 45 is right here, and you'll notice there's no data point there. So if you read between the data points, like so, that's called interpolating. You interpolate back to what you think that belongs to. Extrapolating means you go beyond. If you go beyond the data points, you're going past your data points. So if I extrapolate my data here beyond the data points like so, if I go for what will be the temperature after heating 60 and 70 minutes, 60 is approximately right here on this graph. We extend the data out, and we would say the temperature is at about 80 now. And if we extrapolate farther to 70 minutes in, we would say now the temperature should be around 90 degrees Celsius. So extrapolating is reading beyond your data points you already have. Now, if we apply the idea of interpolation, extrapolation here to our graph we did earlier in the page here, a couple questions for you now. Number 7, what would be the volume of a 30-gram sample of ALB? So go ahead and answer this and enter your answers into Edpuzzle, and then unpause to see the answers when you're done. Alright, so for number 7, we go to 30 grams. 30 grams is right about here. Notice how it's not on the graph here. So we're reading between 2 points. So the method is called interpolation. So I'll write inter here. Interpolation. And when you interpolate, it looks like the value would be somewhere around maybe 10-ish. So about 10 centimeters cubed would be our answer for number 7. Okay, now try number 8 to answer this question as well and enter your answers to see how you did. Okay, so we're looking for a 60-gram sample. If you go to 60, 60 is over here. This is beyond our data points, so the method is called extrapolation. You're reading beyond your data points. And extrapolating and going backwards now this direction, maybe somewhere just above 20, so approximately 21, 22 centimeters cubed would be the approximate volume when you have a 60-gram sample. And that is called interpolation extrapolation. Alright, and lastly, I'd like to take a look at directly related data and inversely related data. We will actually take a look at these in class, so you can be done now. Good job on graphing.